In this example, we're going to be solving a linear equation. Again, we have fractions, but we have binomials in our numerators, right? We have two terms here in our numerator. So it says to solve for w, and we want to do the same steps that we've been doing in order to solve an equation. So first we notice that we have, these are kind of like fractions, right? So I'm going to rewrite the problem. I have 7w minus 4, and all of that is over 8. And what I like to do is I like to remind myself that that numerator stays together. It's a binomial, so I'm going to put parentheses around it. And I'm adding it to 3w plus 8, okay, all over 2. And again, I remind myself by putting parentheses around my binomial numerator. And that all equals 13. And I'm going to go ahead and just remind myself that's the same as 13 over 1. Okay, now I'm going to have to multiply everything by the least common denominator. In our case here, my least common denominator is 8. So I'm going to multiply each one of these terms, this one and my 13 by 8. So if I rewrite it, I have 7w minus 4 all over 8. And I'm going to multiply that by 8 over 1. Plus, I have a 3w plus 8. That's over 2. And I'm going to multiply that by 8 over 1. And that equals 13 over 1 times 8 over 1. All right. Now I can clear my denominators, right? I can clear my fractions. The 8's cancel. 1 and 1. 2 goes into 2 one time. 2 goes into 8 4 times. And my last one is 13 times 8. And if I don't know what that is right off the top of my head, whoops, which I don't, I'm going to go ahead and erase that real quickly. So let's see, I'll do it. 13 times 8 gives me 24. It gives me 104. Okay, so that was 104. So I'll go ahead and I'll rewrite my equation. I have 7w minus 4 plus, I have a 4, and I want to multiply that by the binomial 3w plus 8, and all of that equals 104. So now that looks like a much more reasonable equation for me, right? So I have 7w minus 4, and I'm going to use the distributive property to multiply the 4 by everything inside the binomial. That's why I put the parentheses out there to remind myself. So I get 12w, and plus 4 plus times 8 is plus 32, and that equals 104. Now I combine like terms on each side of the equation first. So I have 7w plus a 12w gives me 19w's. And I have a minus 4 and a plus 32. And that gives me a plus 28. And that equals 104. Now I try to get my variables on one side and my constants on the other side. So I subtract 28 from both sides. And let's scroll that up a little bit. So I have 19w equals, and what's 104 minus 28? I have 104 minus 28. 14 gives me 6. Borrow, I got a 9. I have 76. That equals 76. And then to get w by itself, I divide by the coefficient. So I get 19 cancels. So I get w equals 76 over 19. So now the question is, can 76/19 be reduced? And it's not obvious at first, but if I look, I'm trying to think of, does 19, I know 19 is prime, so I ask myself, well, does anything times 19 give me 76? And I can look at my last number here, right? So I have a 6. I'm thinking, well, what times 9 might end in a 6? And I think to myself, well, maybe 4. Let's try 4. So I have 36. 9 times 4 is 36. 4 times 1 is 4, plus 3 is 7. Sure enough, so 76 works. So 76 divided by 19 gives me W equals 4. And that's the simplest form of the answer. So I can go back and check this also. Let's go back and we'll check it. Okay, so now we want to check. We have W equals 4. And our original problem was 7W minus 4 all over 8 plus 3W plus 8 all over 2, and that should equal 13. So we found that W equals 4, so I'm going to go ahead and plug that in, and I get 7 times 4 minus 4 all over 8 plus 3 times 4, because remember my W is now 4, plus 8 all over 2. And I want to know, does that equal 13? So let's work out everything on one side. So I have 28 minus 4, that's in the numerator of the first fraction. That's all over 8, plus 12 plus 8 all over 2. So I have 24 over 8 plus 20 over 2. And actually I can reduce each of these fractions, right? 24 over 8 is just 3. 20 over 2 is just 10. So I get 13, and sure enough, 13 equals 13, so I came up with the right answer.